This video is about how to do a regression in PSPP. So we have two variables, practice test and state test, and we would like to predict the score on the state test based on the practice test. So we go here, analyze regression, and we pick linear regression. Linear is for if your dependent variable, your criterion variable is continuous, and binary logistic is when you have a criterion variable that is 0 and 1 or 1 and 2 when you have two categories. For example, if you would just predict if somebody passed or failed the state test, we would do binary logistic. Here we picked a linear regression, and then first of all the dependent variable is our outcome, the thing that we're trying to predict. This is the y, the left side of our equation. So this is our state test. And then the independent variables are predictors. At this point in time we just have one predictor. It's the practice test. It's independent. So the state test depends on what our practice test was. Then statistics, we choose the coefficient, the R, the explained variance, and the Anova table. It's fine for right now. And then saving, we're choosing the predicted values and the residuals. So PSPP will enter a new column for predicted values. For each person, we'll enter the score that we predicted, and then the residual is the difference between the predicted score and the actual score that the person had. So continue and hit OK. So you see here we have two columns that were added. Predict 1 is the predicted score, and residual 1 is the difference between the actual score here and the predicted score. So the first person had a score of 45 in the practice test. Based on our regression, we predicted that this person would have a score of 43.75 on the state test. Now if we compare that to the actual score on the state test, it was 40. So 43.75 minus 40 is a difference of 3.75. So the person is 3.75 points lower than what we predicted. Then the next person had the same score, 45, also in the practice test. So therefore, we also predict the exact same score, 43.75. But now when we compare this one to the state test, we see this person actually scored 46 points. So this person actually was 2.25 points higher than what we predicted. Next person, 46. Right, so this one we predict a little bit higher, 44.42. Then when we compare it to the actual score, 37, we have a difference of 7.42. So this person was 7.42 points lower than what we predicted. And we keep doing this. So then what we have here is all the residuals, the differences between what we predicted and what we actually observed. Alright, so let's go into the output, and we're going, so what you see here first is the syntax here. Regression, the variables is practice test, that's our predictor. The dependent variable is state test. And then statistics are the coefficients, the R, the explained variance, the Anova table, and which is not an Anova like we learned about the one Anova. It's just Anova table, and I'll tell you guys a little bit more about that in just a minute. And then save the predicted values and the residual values. So let's go down here first, the coefficients. This is what we actually really want to see. So we have for the constant, the beta is 32.57 to be the 0. This is our intercept here. And then for the practice test, we have a beta of 0.67. So this would be our beta 1. So if you go up 1 point on your practice test, you will have 0.67 points higher in the state test. And then we have the standard error associated with these two values, and based on that we're calculating a t-value. So this is 0.67 divided by 0.20 gives you the 3.35, and then for a sample size of 10 we test the significance of this. So this is highly significantly different from 0. So you would conclude that this is a significant predictor for the state test. Now, what's the difference between this beta and this beta? This beta is the unstandardized beta. It's in the units of measurement that the tests are in. So that means 1 point up in practice test is 0.67 points up in the state test. The standardized coefficients are measured in standard deviations. So the way you would read this one is, if you go have a practice test 1 standard deviation higher, your state test is going to be 0.76 standard deviations higher. So 1 is in the measurement in the actual points on the test, and this here is a measurement in standard deviations. The advantage of standardized coefficients is that you can compare them with each other, with other results. For example, we could make another test that goes from 1 to 20, right? This teacher could develop another practice test from 1 to 20, and then we could do the similar study, but then the points, right? If it would go from 1 to 20, an increase of 1 point would mean something else than if we have this practice test that goes from 1 to 50. However, the standardized coefficient would be comparable because we don't have to worry about what scale the measurement is on. If it's on 20 points or 50 points, it's just based on the standard deviations, so we could actually compare different tests with each other. Okay, so we know the practice test is a significant predictor, and now if we go up to the Anova table, this is, you don't really have to look at it that much because it just tells you if your regression, this is this component, this line here, if your regression explained more of the total variance than your residual. So we're doing the same thing again as we did with for the Anova test. We are comparing the regression here, the mean square of this 248.9 divided by 22 gives you an F value of 11.22, and with the degrees of freedom of 1 and 8 you get a significance of 0.01. Now what you also can imagine is this: the total sums of squares is 426. Your regression covers 248.9. So if you look at percentage-wise, 248, if 426 is 100% of the variation, then 248 is about 58% of the variation. So with your regression, you explain about 58% of the total sums of squares. 177.5 is sums of squares that you can't explain. And that brings us to the very top here, which actually is this 58% I was just talking about. You can also see this here, the R square is 0.58. So it means you can, with knowing the practice test, you can explain 58% of the variation of the state test. And you can get this number simply by squaring the regression coefficient here. If you square 0.76, you get 0.58. So this is how you do a regression in PSPP.